Hi everyone, in this video we have a piecewise function and you have to solve 4 parts. The first part, you have to find limit g of x when x goes to infinity. And as you know, we have in piecewise function 2 intervals. The first one, x greater than 2, so you have to find limit when goes to infinity from this interval, from x greater than 2. So limit g of x when x goes to infinity is limit of 3x squared minus 10 divided by 49 minus x squared when x goes to positive infinity. And as you know, if you have a polynomial divided by a polynomial and limit goes to infinity, you have to take the highest power up and the highest power down and cut the other terms. So we have limit 3x squared divided by negative x squared when x goes to positive infinity. Now cancel x squared with x squared, you will get negative 3. For the second part, we have limit g of x when x goes to negative infinity. Negative infinity is less than 2, so you have to find the limit from the second interval, x less than 2. So limit g of x when x goes to negative infinity is limit the function 3x minus 1 divided by 1 minus 6x when x goes to negative infinity. And as you know, polynomial divided by polynomial and x goes to positive or negative infinity, take the highest power up divided by the highest power down. We have negative 6x when x goes to negative infinity. Now cancel x with x, you will get 3 over negative 6, which is negative 0.5. So now in part 3, you have to find the horizontal asymptote line. So you have to find limit g of x when x goes to infinity and x goes to negative infinity. And we found them in the first part and the second part. So we have negative 3 and we have negative 0.5. So the horizontal asymptote lines for these two questions are y equals to negative 3. This is the first horizontal asymptote line, first one, and the second one, y equal negative 0.5, and this is the second horizontal asymptote line. Now what about vertical asymptote line in part 4? As you know, to find the vertical asymptote lines, you have to take a function, then make denominator equal to 0 after simplifying. So we have two functions. This is the first one and this is the second one. So we will start with the first interval, x greater than 2. In this interval, we have the function 3x squared minus 10 divided by 49 minus x squared. So you have to take the denominator of this function and put it equal to 0. And you will get that x equals 7 and x equals to negative 7. Now we are talking about the interval x greater than 2. This function applies in the interval x greater than 2. Now x equals 7, it's okay because it belongs to the domain of this function. So this is the vertical asymptote line. For x equal negative 7 is not greater than 2. So it is not in the domain. So x equal negative 7 is rejected because it is not in the interval from 2 to infinity. So in the first interval, x greater than 2, we have the vertical asymptote line x equal to 7. Now we're going to go to the next interval, which is x less than 2, x less than 2, the function is 3x minus 1 divided by 1 minus 6x. Now you have to put the denominator equal to 0, and you have to solve this equation by move negative 6x to the right hand side, or add 6x to both sides. You will get 6x equals to 1 divided by 6, x equals 1 over 6. Now 1 over 6 and the interval from negative infinity to 2, because 1 over 6 is less than 1 over 2. So x equal 6 is the second vertical asymptote line. So this is vertical asymptote line 2, and this is the first one. So we have two vertical asymptote lines. The first is x equals 7, the second x equals 6, 1 over 6, sorry, 1 over 6. So pay attention, when you have piecewise function, you have to see the intervals firstly, and that's it. Thank you.